Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nuruddin bin Johan and my matrix number is AE1800041. So now I'm going to present for the simulation part in the PLC on the Open PLC simulation for the activity 1 until the activity 4. So we start with the activity 1, which we have three equipment, which is the first one is PB1, PB2 and also our output lamp, which is the LED. So the condition of our PB1 and also the PB2 is normally open contact. So first of all, we have to verify our equipment by do the documentation by click the add button first. So we click 3 because we have three equipments. So first of all, uh, we we write here PB1 as our push button 1, and this is we change to bool, and the documentation is push button on, and another one is our PB2, and we choose bool, and then this is push button off, and this the last one is our LED lah, our lamp. Then start is bool, and this is our output lamp. We want to observe the output lamp, either it is functioning or not when we sorry we do the we do the trick of force through and also the force pulse. Then after we verify our equipment, we start to we start to do the ladder diagram. And that the first one is we have to do the input terminal. So this is power rail. So this is left power rail means our input, and the right power rail means our output. So we put the left power rail as our input, and then we put another we put the PB1, which is contact. So since our PB1 is normally open contact, so we just choose the normal condition. We click PB1 and we just uh, put here, and then we put another PB2 contact also. So since our PB2 is also is normally open contact, so we just choose normal and we choose PB2, and then it is automatically arranged based on our table here. So PB1, PB2, and also the last one is our LED or lamp. So for lamp we choose coil. So the last one is we add another power rail. So we choose the right power rail as our output terminal. So after that we connect all the equipments. So we have finished the ladder diagram. So and then we click the run button here. So the display shows here is PLC started, means our simulation is okay and no error. So we start to do the debug simulation or debug instance. So we can see here the green color means it is connected. Connected. So we can see here our LED is not turned into a green colors, means that the LED is not working since the connection here is not fully connected. So we will doing the force through and force fast trick. So we try to change it we try to force through the PB2. So it is still not connected, so we click here force through. So now our LED is functioning since the all connection is connected, is fully connected. So this is for activity 1, and then we proceed with the activity 2. So the activity 2 is we have to change the PB1 since our PB1 is normally close contact. So we just stop the simulation, and then we click here, and then we proceed. We go back to the first ladder diagram. So we change. So we change our PB1 into negated lah. Means our PB1 is normally close contact. So at here we also change, you know. So this is for activity 2. So we proceed by click the run button. Sorry, we have in activity 2 the LED is changed with the siren. So we click the siren, and then we proceed by click the run button. So PLC started, means our simulation is okay and no error. So we proceed by click the debug instance. So we can see here the green color means it is connected. So it is only connected at the PB1, and the PB2 and siren is not turned into the green color, means the siren is not working. So we have to change the PB2 force through. We have to choose force through for our PB2, and then we can see here the siren is now functioning. So in order to make sure the siren is functioning, we have to make sure the PB1 is force fast. And so uh, uh, it is same as a logic gate, or what only one of the PB1 should turn to 1 in order to make sure our siren is 1, which means on. So we proceed the activity for the activity 3. So we can delete it. So for activity 3, we have to change our PB2 to normally close contact. Our PB1 is normally open contact. So the siren is also changed to a LED back. So LED. So this is we change to normal condition. And the PB2 we change to negative, since our PB2 now is normally close contact. So now we can run. Sorry. So okay, now the display shows here is PLC started, means the circuit is okay and the simulation has no error. So we start we proceed with the next procedure by click the debug instance. So now we can see the PB2 is turned to green color, and the PB1 here is also turned to green color. So it means that uh, the connection is connected here, and also at the PB2, and the LED is not functioning since the PB1 is open circuit lah. Sorry, the open connect open is normally open circuit lah. Sorry. So we have to in order to make sure the LED is turned on, we have to choose force through at the PB1. So we can see here the LED is now functioning, since since the connection is already fully connected. And then we proceed by doing the last activity, which is the activity 4. So for the activity 4, we have to uh, make sure the PB1 and PB2 is in normally close contact. So we change the PB1 to negative, means it is close contact. So now our our PB1 and PB2 is in a close contact. So we try to run. So the display shows here is PLC started, means the simulation is okay and there is no error. So we try to click the debug instance. So now we can see the LED is now functioning. So this is because the connection from the negative from the input here to the output here is already fully connected, so that our LED is functioning. We have to make sure that the PB1 and PB2 is force fast in order to make sure the LED is functioning. If we change to force through here, the LED will not functioning. So that's all for the simulation for activity 1 until activity 4. So thank you.
Hi, so now I will proceed to demonstrate a ladder diagram given for figure 5.5. So now our circuit is done, so we try to run the circuit first to see the result. So we can see that our circuit is connected successfully. So now we debug instant the circuit to see the, uh, so, so next we try to force through the push button. So the lamp is So after we falls through the push button, the lamp is turning on. So next I will demonstrate the given ladder diagram in for figure 5.6. So we start with Alright, so now we try to run the simulation first. So now our circuit is successfully connected. So we try to debug instance. Alright, and now we try to force through this push button, and then we can see that in 5 seconds the lamp is turning on. So now I will continue to demonstrate the given ladder diagram for figure 5.7. So now we try to run our simulation first. So after we successfully connected the circuit, so we try to debug instant. So when we force through the push button one, the lamp is not turning on, and we force the lamp after for 5 seconds. The lamp is still not turning on. So we try to force the push button one and force through the push button two. The lamp is still not turning on. So that is all for activity 5.7. So now I will start to demonstrate for the ladder diagram for figure 5.8. So next we try to run this circuit. So what happened next, we try to debug instant. So it's nothing here, it's still 0. So we have to force through this push button first, and then it shown 1, count 1, and then we force false, and then we through the push button again, and then it count increase to 2, and then we force false, and then we force through again, and then it increasing to 3. So then it will this timer will count until 5 seconds for the LED to turn on. So that is all. I will pass to my friends. Thank you.
Hello, my name is Nurila Bintu Mat Zamri. My matrix number is CE180108. I'm going to present activity 6 to activity 12. This is activity 6 as shown in the PLC editor. In activity 6, we use push button, relay, lamp, timer as normally closed. So I'm going to run this PLC. Okay, after we run the PLC, click the debug here, and I will turn on the push button, and the timer will start counting to 5 seconds. So when the PB is turned on, the output relay and the output will normally open, and the output lamp will directly turn on. The output timer and the timer which is normally closed will turn on after 5 seconds. As the PB stays in on condition, the timer will repeatedly turn on after 5 seconds, and the lamp will turn off for a split moment if the timer is on. So if want to off the lamp, we just need to off the push button. And the lamp will turn off. This is activity 7. Activity 7 have 2 push button. One push button is normally open and one is normally closed. So I have one relay, timer, and lamp. This timer set in 5 seconds. So I've run the PLC and click the debug. So in this activity, we will try to turn on and turn off these two push button. Firstly, I will turn on the push button 1, and the timer will start count in 5 seconds, and the lamp will turn on. If I turn on the push button 2 without turning off the push button 1, the connection will cut off and the lamp will turn off. In the position of push button 2 in on condition, I will turn off the push button 1, and the lamp also will not turn on, and I turn off both push button. Clearly the lamp will not turn on. The lamp will turn on when the push button 1 is turned on, and after 5 seconds the lamp will turn on. Okay, next, this is activity 8. Activity 8 have 2 push button, 1 relay, 1 reset, 1 timer, 1 lamp, and 1 counter and 1 timer. This counter I set it to 2 times, and the timer I set in as 2 seconds. So I have run the PLC and I will click the debug. So okay, we have to turn on the push button twice because we have set in the counter as 2. So let's try. This is first we turn on, and this is the counter here. This is 1 because we only on the push button once. So we turn off and we turn on again, and this counter will count into 2. So when it's count into 2, the circuit will run and the lamp will turn on after 2 seconds. After that, we turn on the reset button, and all this and the lamp will turn off after we turn on the reset button. After 5 seconds, the lamp will turn off and the counter will reset it again. So if we want to on the lamp, we have to turn on push button twice. This is activity 9. We have 2 push button, 1 relay and 1 lamp. So I run the PLC and click debug. Okay, first I want to turn on the push button 1. Okay, when we turn on the push button 1, the output relay and the lamp will turn on. After that, we turn off the push button 1. Okay, the output relay and the output lamp will still on as it receives the current from the relay 1, which is normally open. The PB2 will act as stop button as we turn it on. So we turn it on, so the lamp will turn off. Okay, this is activity 10. It has 2 push button and 2 push button to stop. We have 2 relay and 2 lamp. So we have I have run the PLC and let's click the debug. So when push button 1 is turned on, the output relay R1. Okay. When the push button 1 is turned on, the output relay R1 will turn on and the lamp will also turn on. Then if we want to stop the lamp 1, we will have to turn on the push stop button 1 and the lamp will turn off. So when if you want to turn on the lamp 2, we have to on the push button 2 and the lamp 2 will turn on, and if you want to off, we have to turn on the push button stop 2 and the lamp 2 will turn off. But if we keep the push button 1 off and we turn off back the push button 1, the lamp will still turn on as it R1 normally open as the current source. The result when the turning on and off the PB2 will be the same as the PB1. As example, when we turn off this and when we turn on this, the lamp will turn off, but when turn off the push stop and we turn off the push button, the lamp will turn on because the R1 is the source of the current. Okay, Okay, this is activity 11, which is push button, two relay, two lamp, and one timer and one counter. So I've run the PLC. Let's click the debug. So when the PB1 is turned on, the coil R1 and the output lamp 1 will turn on. Okay, I have turned on, and the output lamp 1 will turn on. But when the PB2 is turned on and the lamp will turn off, then the system will turn off. So that means PB1 act as a start button and the PB2 act as a stop button. Okay. Firstly, when the PB1 is turned on, the relay R1 is active, and automatically the counter will start to count. So the counter is set to 3. So that means we need to turn on and off push button 1 3 times. It's 2, 3. Okay. So that after 3 times, the output lamp 2 will turn on in 5 seconds, as is set in timer, and after that the R2 coil will be active. The R2 coil indicates the R2 contact. So when the R2 is active, the counter will be reset to 0. So to turn off the system, we just need to turn on the stop button PB2. So to turn off all the system, we need to turn on the push button 2, and all the ladder diagram will turn off. So this is the last activity. It's activity 12. It has one start button and one stop button. Relay 1, relay 3, reset, lamp 1, lamp 2, timer and counter. So I have started the PLC. Click debug. Okay. When we run the ladder diagram without without turning on any button, the contact R3 allows the current to activate the timer. After 2 seconds, the lamp will turn on. The lamp 2 will turn on. When we turn on the reset button, and start button, we turn on the reset button and the start button. The mechanism of reset button is from normally closed to normally open, and for start button from normally open to normally closed, and the lamp 1 will turn on. So after we turn on the start button, the coil of R1 are active. So the function of contact R1 under the start button is to hold the start button until we turn on the stop button. Also, when the contact R1 is active, the counter start to count until 1, and the coil RT and lamp 1 are active, means are on. So the contact R3 operates from normally closed to normally open, and that's why the lamp 2 will turn off. Generally, lamp 1 and lamp 2 cannot turn on in the same time. Okay, that's all from me. Thank you.